All right, I'm going to tackle the review exercises from Chapter 2. These are the questions that I asked you to answer. R2.1, explain the difference between an object and an object reference. Well, hard to do without pictures here, but so an object is stored somewhere in the computer's memory, and you don't actually know where that is, but it contains all the code and memory space necessary to house that object. So, for example, if your object is a cat, and a cat has an age and a weight and a number of legs, 3 variables, and the computer needs to reserve space for every cat that's created. So if you create a cat called Fluffy, it reserves enough space for those 3 variables and any attached code it needs to complete a cat object. But you don't actually know where that is stored in the memory, and you don't care. It doesn't matter where it's stored. You have a reference to that object, and that's what you create when you name it. So if I say cat Fluffy equals new cat, Fluffy is the name of my object, and that is a variable that holds a memory address. So Fluffy, if you were able to look inside that variable, you'd see the address of where in the computer's memory that object was being stored. So that's how you can, that's the difference between an object and an object reference. Okay, R2.2, explain the difference between an object and an object variable. Okay, it's very similar. The object is stored somewhere in the computer's memory. The object variable is that name that you created for it. So Fluffy would be the object variable. And the object itself, Fluffy itself, is somewhere in the computer's memory. Explain the difference between an object and a class. This is R2.3. So the object is the cat that was created. The class is the factory that makes all the cats. Okay? So if I have a, let's use an example that you guys have used in the code. So the rectangle class describes what all rectangles look like. And they have a starting x, y coordinate. They have a height and a width. And that is what makes up a rectangle. And so with that description, you can punch out as many rectangles as you need. So I can have my rectangle, I can have your rectangle, I can have big box, little box. I can name them whatever I want to. I can create as many rectangles as I want to. But the class is rectangle with a capital R. And the object is all the little rectangles that I create, my rectangle, box, whatever I name them. So think of the class as a description of what the object looks like. Think of it as a factory that produces all the different objects that you need. The actual objects are what comes out of the factory. Okay, R2.9, find the errors in the following statements. In letter A, we've got rectangle R equals a bunch of numbers. Well, you can't do that. You need to tell it that it equals a new rectangle. We're missing the new keyword and the name of the class. So rectangle R equals new rectangle followed by that. This is a constructor method. It's part of the rectangle class. If you don't put a rectangle in front of this is just a bunch of numbers in parentheses. Okay, letter B. Double named width is equal to a rectangle constructed with this and then calling the getWidth method on that. Well, the rectangle doesn't exist yet, and so you have to create a rectangle separately and then say, my rectangle.getWidth. That's the only way you could do that. Letter C, rectangle R. These are supposed to be on 2 different lines, but my numbering system got messed up, so these are 2 different commands, one after the other. Rectangle R, okay, so we have a rectangle named R, and then we say r.translate 1525. Well, we never set R to an actual new rectangle. This just created a variable that is set up to hold a rectangle, but there isn't a rectangle in it. So you need to say rectangle R equals new rectangle and then give it the information. Then after that, you can call r.translate on your rectangle. Okay, letter D. R equals new rectangle, r.translate far, far away. Okay, the translate method needs 2 numbers, not a string, so that will not work. And this assumes that the rectangle has already been created, rectangle R, kind of like the last one there. Okay, R210, name 2 accessor methods and 2 mutator methods of the rectangle class. So accessor methods, all they do is give you information about the object. So for the rectangle class, get width and get height, those are accessor methods. They just access the data and give it back to you. They don't make any changes. Mutator methods make changes to the class. So the first one that comes to mind is the translate method, because that actually changes the XY coordinate for that object, and that moves it to a new spot. Let's see, another mutator. Let's take a look at the API here. So I'll jump over here and we'll go to Java AWT. We'll go down to classes and we'll look for rectangle, which is right there. And we can just kind of look through the methods here. And so we have a number of these actually are, a number of these are actually mutator methods. All these get methods are accessors, so get bounds, get height, get location, get size. Those are all accessor methods. Anything that says set in it is going to definitely be a mutator. Set bounds, set location, set size. Here's one called toString. This returns a string description of the rectangle, so you can print out a description of what the rectangle is and what its values are. That's not making any changes to the rectangle. It's just getting some data and turning it into a string so you can print it in the console window. And so that is an accessor method. Translate is a mutator method. I think some of those ones at the top, like add point, create intersection, that returns a new, it may not make any changes, but so these are mutators. So there you go. Short answer is get width and get height are accessors, and then set location and translate are both mutators. Okay, R2.11, look into the API documentation of the rectangle class and locate the method void add int new x int new y. Read through the method documentation, then determine the result of the following statements. Rectangle box equals new rectangle 5, 10, 20, 30, and then box.add 0, 0. So let's take a look. Okay, so it's right at the top here. It's a void method, doesn't return anything. Its name is add. It takes in two parameters, one int called new x and another int called new y. And the description says it adds a point specified by the integer arguments new x, new y to the bounds of this rectangle. So it takes this x value and this y value and adds that to the rectangle bounds, which is basically the width and height of it. And so let's take a look at what that does in a rectangle. So here's a rectangle from an earlier problem. And so we have rectangle box, new rectangle, and then we draw that rectangle. I'm going to comment out the translate instruction, and instead I'm going to say box.add 0, 0. And then we'll draw it again and we'll see what happens. And what you'll see here, whoops. Okay, so what you can see here, I had to open my empty frame viewer because that's the one that draws the rectangle with the main code. Whatever code that you have that has main in it, if that's open and you run it, that's the one that'll run. I ran an internal class, and so what it did was it ran the previous main code that I had used, which was the alien face one. So anyway, so where'd it go? So what you can see here is the original rectangle is this small one, okay? And then when we added 0, 0, it said, oh, I need to add 0.00, and the bounds has to extend to meet that point. And so it went out to there. So if I close that, and if we comment this and this, so we only get the original, and run it again, then you can see that's the original. It's a little bit detached from the top corner there. It's at 5 and 10. And then if we go back in and add those back in, what you end up with is a new point and the bounds extended to meet that. So the first rectangle draws there, the second rectangle draws bigger. Okay, R2.12, find an overloaded method of the string class, and we have to do that in the documentation. So we'll go here, and we'll go to all classes and string, and here is the string class, and let's go down to the methods. And so what overloads means is the method name will be the same, but there'll be different types of parameters. So if we see any of these that are repeated, that's an overloaded method. So let's scroll down here. Okay, here's one. So we have format method and another format method. And they're exactly the same, except that this one has 1, 2, and then an unlimited number of arguments. And this has 1 specified, and then an unlimited. So the difference is this guy here. Because these two parameter lists are different, if you wanted to call this one and you included 2 things and then your objects, it would know this is the one you're looking at. If you used it and you called 1 thing and you didn't give it a locale, you just gave it a string and then you called your objects, then it would know you were using this one. Maybe we can find a different example that's a little closer to something we've used before. So here's one, index of, index of, index of, index of. It's the same method, but there's 4 ways to call it. You can give it 1 integer, which is the first occurrence of a specified character. You can give it 1 integer called that, and then another integer, which is starting at a certain index point, reference point. Here's an index of where it uses a string, so you give it a string to search for, and then a string with an index option. So that's those are examples of overloaded methods from the string class.